So the next thing we want to cover is mass. Mass we typically measure in terms of kilograms. So central to all training in athletics is the term force. All force is mass times acceleration. We often measure force in terms of newtons, and all a newton is the force required to accelerate 1 kilogram, 1 meter per second squared. So if we have an object that weighs 1 kilogram and we accelerate it at a rate of 1 meter per second squared, this equals 1 newton. So if we apply 1 newton of force to a 1 kilogram object, that means it's going to accelerate at a constant rate of 1 meter per second squared. So if we did this for 5 seconds, this means the object would be traveling 5 meters per second at the end of that 5-second interval. If we apply 2 newtons to a 1 kilogram mass, then that means every second it's going to accelerate 2 meters per second. So if we have a 1 kilogram object and we apply 10 newtons to it, after 1 second of applying that force, the object will have a velocity of 10 meters per second. If we have a 10 kilogram object and we apply 10 newtons of force, after 1 second that object would have a velocity of 1 meter per second. Likewise, if we apply 10 newtons of force to a 10 kilogram object for 5 seconds, at the end of that 5-second interval, the object would be traveling at 5 meters per second as opposed to 1 meter per second, since we applied the force for a longer period of time. Next, we look at gravity. So the gravitational force on Earth accelerates all objects independently of air resistance, 9.81 meters per second squared. So what does this mean? Well, gravity interacts with objects with mass so that all objects, regardless of how much mass they have, will accelerate at the same rate when inside of a uniform gravitational field. So a 1 kilogram object and a 100 kilogram object will increase their velocity by 9.81 meters every second. Well, in order for that to occur, gravity has to apply 9.81 newtons to a 1 kilogram object and 981 newtons to the 100 kilogram object for those objects that have the same acceleration rates. So this is the careful distinction. So when we look at force production, a lot of times we have two components that we're primarily concerned with in most training contexts. We have the vertical component where we're directing force upward against the force of gravity, and then we have the horizontal component where we're not exactly directly fighting any particular force when we're traveling at low velocities. So there is zero force here. When we're traveling parallel to the Earth's surface, we're not directly fighting gravity in that movement. So if you pick up an object and you walk with it over 100 meters, that horizontal component, you didn't produce any horizontal force in that direction, aside from the period where you accelerated the weight and when you decelerated your movement. This means that for there to be any measurement of force, we need a change in velocity when no gravity is present. And this concept applies purely to situations when you're not opposing gravity or some other force that is attempting to oppose your movement. And what we think of that as usually friction of some kind. Friction can include the resistance you feel whenever you push a sled across the ground, or air resistance when you're running with a parachute, or even the friction in the wheels of something that's really heavy that you're trying to push. Alternatively, when we look at up and down movements where we're directly opposing the gravitational field, we experience a large amount of force despite the fact that there is no change in velocity, because gravity itself is constantly exerting a force that would otherwise accelerate that object down, and you have to apply an equal and opposite force just to hold the object still. So, and this is what you see with a scale. When you stand on a scale and it says you weigh 200 pounds, that's because gravity is exerting a force on all the mass in your body that the scale has to apply an equal force upwards to prevent you from falling through the scale. And the amount of force that you and the scale are applying to one another is known as your weight.